I'll say this on the recording. Thank you to those people who emailed me for not being able to make it. Appreciate you. So good morning, everyone. It is National Pharmacist Day, which I thought was cool because our pharmacy workers are essential workers right now, and they're really, really helping us out. Everybody thinks about doctors and nurses, but without pharmacy workers or pharmacists, we're able to get the medicines that we need in order to feel better. So super pumped to learn a little bit more about this career. I don't really know that much about pharmacists. Does anyone know? Does anyone know what? Does anyone know a pharmacist? Wow, I'm having a hard time this morning. Does anyone know any pharmacists? Anybody's parents a pharmacist? Yeah, Lily. Who do you know?
My aunt.
Your aunt's a pharmacist. That's awesome. Cool. Yeah, so pharmacists make 100 on average, or like the median is $121,000. So pretty solid job. I did learn, I didn't know this, pharmacists have to go to pharmacy school, which is 4 years as well. So that's pretty wild. Coca-Cola, Pepsi, Dr. Pepper, and ginger ale were all invented by pharmacists, which I was like, oh, shout out to them. I love a good soda. That's awesome. And then as I was reading, I found out that there's one US president who was a pharmacist before he was president. Does anyone know who it is? Does anyone know who it is? Anybody? Anybody? Nobody knows? Not Franklin. Good guess, though. It was Humphrey. Does anyone know who that is? Sometimes I feel like if they're not in this early 1700s, like George Washington, John Adams, right? And if they're not like in our most recent ones, right, then we forget who they are. But President Humphrey was a pharmacist before he was president. It's pretty cool. Hello, Ale. Welcome, everyone. Thank you. Please make sure that you have taken attendance. And we will jump in here. All right. We're gonna jump in. All right, I'm really excited to talk with you all, particularly. I want to say welcome back. I have missed your faces and your little boxes on my screen and your little words in my chat. I really appreciate you all coming back. I'm also really excited because one thing that the new schedule has allowed for is for us to be accelerated all together. So that's why you're seeing just 27 of us on this call. This is our accelerated class, so I'm super pumped to have you here. A few things that will be like slightly different. You will have, sometimes you'll have generally the same assignment as the other Algebra 2 classes, and sometimes you will have a different assignment entirely. We'll move a little bit faster, so you may do an assignment on Thursday that the other classes might not get to until next week. Or we might do something that the other classes skip entirely, just because I know you all want to move a little bit faster and have that time to work together. So we're gonna jump into notes and assignments. As a reminder, I'm gonna go ahead and open up my breakout room. When I do so, this is so that if you want to go to a quiet space to watch the video, you're welcome to. Right, so if you would like to watch the video for today, it is linked in your Canvas. It's also linked in your assignment and notes pages for today. And you can check that out and watch the video. So I'm going to go ahead and open up the breakout rooms. Let me pull those up. Breakout rooms. This will let you have a quiet space. I'm also going to allow you to choose the room. So if you have the Zoom download, the new Zoom like update, then it will let you like actually choose which room you would like to go into. I'm going to go ahead and open. All right, so you can go ahead and pop into those rooms if helpful. Otherwise, I'm going to do the live action here, and we're going to be working on assignment 17. So, or I'm sorry, 18. So go ahead and jump into those groups if you'd like. If you want to stay with me, you're totally welcome to. I'm going to switch over and share my screen from my iPad. Let's do this. All right. If you're going to stay with me, just pop off in the chat. Just say like, hey, Miss Mac, I'm sticking with you. I want to do live action. That'll just let me know that you're hanging with me. So let me know in the chat. Thanks, Lily, for letting me know. Let me know in the chat. Awesome. Cool. You can just give me a thumbs up if you want to. You could say that you're going to hang out with me. Nice. Thank you. Thank you. Thank you, Lily. Thank you. Thank you, Ale. Thanks, Amy. Thanks, Alfredo. Thanks, Elizabeth. Thanks, Angelica. All right. So we're going to jump in. Can you all see my screen? Yes, yes. Hopefully. Cool. Awesome. Okay. I would love, especially because this is such a small group of people working together today. I would love if you would come off mute and let me know. I had a question, can I use my Apple Pencil to do notes or does it have to be on a Google Doc? No, you can totally use your like iPad, Apple Pencil, whatever you want to take notes. I just need to see that you wrote it down somewhere. If you want to do that digitally, you're welcome to. If you want to type it out, you're welcome to. If you prefer to write on paper and take a picture, that is great too. But any format is perfect for me. What I was saying though is I would love to hear your voices. So if you've got them on you this morning, that would be awesome for me. So today we are adding, subtracting, and multiplying. You have done all three of these things in the past. We are just putting a different format on it. And the new format is going to be in this section here. I won't say new for sure, but definitely like this is something we haven't talked about this year so far. So what this means here, this means F, the way that I read this section here, F plus G of X. So F plus G of X. That's how I'm going to read this item here. Basically what that means is I'm going to take the F function and the G function and I'm going to add them together. So I'm just doing this. It does not mean that I am like adding in more. I'm not going to like multiply that X at the end. That's not what that means. It just means I'm going to take the F equation and the G equation, add them together. It's the same as saying sum, which you all know means addition, right? We also have the subtraction version. So F minus G of X, that just means F of X minus the G of X function. And we're going to find the difference of F of X and G of X. Okay, so difference again, meaning subtraction. And then the last one is multiplication. It's usually written in one of two ways, F times G of X. So FG, remember when they're smashed up against each other, it just means multiplication, F times G of X. And that's the same as saying F of X times G of X. So when we're at big ideas here, when we're adding and subtracting, we're combining like terms, right? We're just taking the things that are similar, we're putting them together. And then when we are multiplying, we're either using the box, if you like the box, or FOIL, if you know what FOIL is. I know Ms. Velasquez works with the box, so that's probably what we're most comfortable with. But if you know FOIL, you're more than welcome to jump in there. So what we're going to see here are some functions. And what this is saying is the F function plus the H function. And we're using the variable X. Right, so if there's an A here, we'd use the variable A. If it was a K, we'd use the variable K. So we're going to do F plus H. So I'm going to grab the F equation, which is 4x minus 3. And I'm going to add it to the H equation, which is here, which is x squared minus 3x plus 1. And this is where that combining like terms comes in here. Do I have any like terms when I go to add this together? Feel free to come off me. Do I have any like terms this morning?
The 4x and the 3x, negative
Mm,
3x.
For sure, we have the 4x and the negative 3x. Any other like terms?
Negative 3 and +1.
Negative 3 and +1. Thanks so much, Antoine. Cool. So we have those ones there, and then we want to start with our x squared since it is our largest degree. So I'm going to start with x squared. I have 4x plus negative 3x would be positive 1x. And then I have negative 3 plus 1 would be negative 2, like that, right? I'm going to double check. It tells me that my variable is x. So I'm going to go ahead and make sure that I have x in my function, and that's going to be my answer. Right? That's going to be how I jump in. All right. So for the next question, it says h plus g, but instead of saying x, it now says -4. Right. So instead of saying x here, it says -4. Any ideas on what it means to turn x into -4? Any ideas? Yeah, thank you for that private chat. It means that we're going to turn x into -4 once we get to the end of the function. So right now, go ahead and take the h equation. We're going to take h of x. We're going to add it to g of x. Go ahead and do that on your paper right now while I grab JR this link. JR, if you can hear me, you should be able to access it by going to the notes page and clicking on the link at the top where it says notes 18, or you can go to the assignment page and click on where it says notes video, or I'm about to drop it in here for you. Should have it there. No problem. JR, for future reference, it should be, it might not be actually, now that I'm looking at this, that's my bad, but it's always linked right here. Wait for it. It's always linked on the assignment in that section there. Thanks for coming back and asking that. Cool. All right. For my people who are with me, we're adding h and g. So I've got x squared minus 3x plus 1, that's h, plus g, which is 2x plus 1. Right, I'm combining like terms. I've got x squared, we got negative 3x and positive 2x makes negative x. And then positive 1 and positive 1 make positive 2, just like that. Cool. Wow. Very similar to our last problem, but slightly different with our signs. And then now that I have my function, right, this is my function with x, and now x is turning into -4, right? So my x's are turning into -4, right? So this x and this x is turning into -4. So I'm going to have -4 squared minus -4 plus 2, like that. -4 squared, 16, of course. Adding 4 plus 2, 16 plus 4 would be 20, plus 2 is 22. So we have here the answer as 22. One thing you might notice, if it says f plus h of x, you're likely going to have x in your answer, right? So you're simplifying in this case, right? You're simplifying, you're combining, you're simplifying using x. If there is a number here, you have a second step, which is to simplify them together and then plug in that additional number. Right? So it's called evaluating. You're plugging in a number for the variable. So if you have a number at the end, that means that your answer is going to be a number. If you are with me, can you send me a fist to 5? Fist is I don't get this at all. 5 is like you're moving too slow, Miss Mac. Let's move on. You can private message me. You can send it to the whole team. 3 is like I need another example. 4 is like I think I'm pretty good. Cool. Thank you. Thank you. Awesome. Thanks for those messages. Appreciate you. Cool. If you are a 3 or 4, let's do subtraction. I think it will be a good example. If you're feeling good about this, we will move a little bit faster for subtraction. So for subtraction, this is saying g minus h of x. So I'm basically saying g of x minus h of x. In the past, some people have thought about this like kind of like distributing onto each of them. So you're doing g of x minus h of x. That can be helpful to remember. So g is 2x plus 1. I'm going to subtract the h equation, x squared minus 3x plus 1, like so. So I have this example here. The negative applies to everything in the h function. So it's going to distribute into each function like this. So negative x squared, I'm going to add 3x, and that negative is going to make this negative 1. I've got 2x plus 1. So I'm going to combine like terms like normal, negative x squared, 2x plus 3x is positive 5x, and positive 1 and negative 1 cancel each other out. So those will be gone. So this would be my answer for subtraction. So no major difference, just distributing that negative in. I'm going to give you 1 minute to try this next one on your own. So f minus g, and then you're going to plug in that number 2 at the end. When you've got an answer, go ahead and direct message me, right? Direct message me what your answer is. All right. So our f equation is 4x minus 3. We're subtracting our g equation, which is 2x plus 1. We can simplify this. If we want to, right, and put them together. Or we could alternatively put the 2 already in here, right? So since I know x is turning into 2, I can put that 2 in here right now. So I have 4 times 2 minus 3 minus 2 times 2 plus 1. So 4 times 2 is 8, minus 3 would be 5, minus 2 times 2 would be 4, plus 1 would be 5. 5 minus 5 is 0, like that. If you want to, you can do what we were doing in the past. So 4x minus 2x would be 2x. Negative 3 minus 1 would be negative 4, like that. And then go ahead and plug in your 2. 2 times 2 would be 4, minus 4 is, of course, 0 as well. So either of those methods will work. You can either plug in at the beginning, or you can simplify, then plug in at the end. Right. Yes, perfect. All right, let's go ahead and jump into multiplication. Give you a second to write down this problem here. We're going to do h times k of x. All right, so for h, we have x squared minus 3x plus 1. times k, which is negative 4x squared plus 3x minus 10, like that. So we're going to multiply these two together now. So we have, so if we had like 4x, this is, you don't need to write this part down, 4x minus 2 times 3x plus 4 or whatever. I'm making up a problem here. If we had this, right, we'd say, okay, I need to multiply each part times each part, which is how many of us learn to use the box. So we'd have 4x minus 2 and 3x plus 4, something like that. 4x times 3x, 12x squared. We'd have negative 2 times 3x, negative 6x, etc., right? And you would combine those things together, right? So we're going to do the exact same thing here, but instead our box is going to be 3 by 3, right? So we have 3 things in the first one and 3 things in the second. So I'm going to have a big old box here. And I'm going to have x squared minus 3x plus 1 and negative 4x squared plus 3x minus 10. I'm going to take a second to set up that box. And then we're going to jump into this part here. So I have x squared times negative 4x would go, negative 4x squared would go in here. So I'm going to have negative 4x to the 4th, x squared times x squared. I have negative 4 times negative 3 is positive 12. There's x times x squared would be x to the 3rd. I have negative 4x times positive 1, negative 4x squared. We have x squared times 3x would be 3x to the 3rd. I have negative 3x times positive 3x, negative 9x squared. 3x times 1, 3x. We have negative 10 times x squared, negative 10x squared. Negative 10 times times negative 3 would be positive 30x. Negative 10 times positive 1, negative 10. You might notice as you are looking here that the like terms that will combine together are in diagonal. So x to the 3rd and x to the 3rd. We have x squared, x squared, x squared. We have x and x, and we have our number by itself. So those are going to be each of the different pieces here. So we would have negative 4x to the 4th to start this part. And we have 12 and 3 make 15. So 15x to the 3rd. We have negative 10, negative 9 make negative 19, and negative 4 makes negative 23x squared. We have 30 and 3 makes 33x. And we have negative 10. Negative 10, like so. Negative 10. So this is my answer for that question there. That's probably the most challenging one that you'll see today in terms of like length of problem, for sure. A 3 by 3 is the most challenging, for sure. All right, so for our last one here, we have g times h. So we're doing g times h, and then we're plugging in negative 1 at the end. We could multiply g times h together and then plug in negative 1. Or as we found out on the last example, we can plug in our number, we can plug in our number at the beginning, and then we don't have to do we can do like the combination at the like all together. So I would recommend that for multiplication in particular, because multiplication can be more tricky. So I'm going to go ahead and grab the g equation, which is 2x plus 1, and the h equation, which is x squared minus 3x plus 1. I'm going to take a moment to write that down. So I have the G equation here times the H equation there. This box would be a 2 by 3, right? 2 by 3. So you do 2 on the side and 3 on the top, or either way, you can flip it. For me personally, since they have this -1 here, I would go ahead and recommend taking the -1 and just plugging it in at the get-go. So anywhere that you see X, you're going to plug in a -1. So in this case, in 3 places. So I'd have 2 times -1 plus 1. 2 times -1 would be -2 plus 1 would be -1. So that is my first parenthesis, my G parenthesis here. I would have -1 squared minus 3 times -1 plus 1, like that. -1 squared is +1. This would be plus 3 plus 1. 1 plus 3 plus 1 is 5. So the second parenthesis is turning into 5. Right, so -1 times +5 would be -5. -1 times 5 would be -5. So for our problems today, we did adding and subtracting. We're very similar. They're just combining like terms, right? In the green box for multiplication, we use the box. It is definitely easier to be able to plug in that number, right? So if you are doing the version that has X at the end, right, then you're combining like terms or using the box. If you are evaluating, which means you're plugging in a number, you can take that number and plug it right in, right? Take that number, plug it right in, and simplify. I definitely agree that the plugging it in right away is easier. So the ones with numbers might be an easier problem for today. I would love to get a gauge for how you are feeling about the speed of the notes today. If this speed was good, if you could go ahead and tell me like the speed was good in the chat. If it was too fast, you can tell me too fast. If it was too slow, please tell me too slow. Either way, so you can tell me speed was good, speed was slow, speed was too fast. Just let me know in the chat where you're at. Cool. Looks like for most of us, the speed was good. Sweet. Thank you. Thank you for those of you telling me it was too slow. Thank you for those of you who are telling me it was too fast. Appreciate that feedback. Thank you to those of you who are telling me it was good for you. Cool. Okay, for your practice today, you are going to have, you're going to pop the picture into your notes. You're going to have these 8 problems here that you have to do. So you'll see there are 4 problems where you're simplifying, and then 4 problems where you are evaluating. You're putting that number in. So you're going to do those 8 here. And then you're going to choose, I know this looks like a lot, so that's why I'm explaining this. It says choose 5, right? So you're choosing 5 of these problems. So you're doing 5 more problems here. So you're doing 13 total problems. That is it. You should have on your copy, you're going to see the answer choices here. And then you'll see the answer choices over here. If you're feeling like this is really, really hard, you have some mild options over here. Mild is the easiest version of these questions. You have the medium questions here. Those are like in the middle if you're feeling pretty good. And if you're feeling like, great, this, I really want to challenge myself, then you have the spicy version here. So you can work on the spicy ones. But you're doing 5 total problems. And then the checkpoint form has 3 questions. So today you're doing a total of 16 questions for your homework. Okay. I am happy to continue working with you or answer any questions, but I do want to release you to work on your assignment. If that makes sense for you. Please let me know if you would like me to go over number 1 with you. I'm happy to, or any of the other questions as well. Otherwise, I will be right here answering questions. Feel free to send me a question in the chat if you have any. Otherwise, your next job is to get started on part 1 of your assignment. Does anyone want a direct link to the assignment? Like, so you don't have to go to Canvas. Cool. Thank you. There's that assignment if you want. I can also put you into a breakout room, or you can go into your breakout rooms now. So you can work on the assignment. You can ask a question. You can head to a breakout room. Those are your options.